quick session on LambdaTest. LambdaTest is a cross-browser and a cross-device testing platform that allows you to perform native app as well as web app testing on both browsers as well as different sets of devices. LambdaTest allows you to perform both manual as well as automation testing on the cloud. Today, I'll be talking about how you can perform manual testing on browsers on both desktop browsers as well as device browsers. What you see on the screen is the UI where you can quickly jump in under real-time testing under browser testing. LambdaTest supports all the browsers available. We support browsers from Chrome, Firefox, Safari, Edge, IE, Brave, Opera, and Yandex from versions starting from the latest to the legacy versions available. We also support all the operating systems and different resolutions. How you can start testing is simply by entering the URL, select the browser, the version you want to test on, any operating system and resolution of your choice. Simply click on start. As soon as you click on start, you'll get a machine or you'll get a device located of your choice. And this particular browser that you is as good as your local browser. Just like you can perform on your local browser, simply right click and click on the inspect element to view the page source, network logs, the console logs, etc. On top of it, there are a few additional features that you provide which will make your life much easier. First one is Marcus bug. Marcus bug captures a screenshot of the viewport that you're working on and allows you to directly mark any bug or any anomaly that you find out while testing on the website directly to your bug marking tool or your project management tool. And that's how LambdaTest supports. Since LambdaTest supports integration with more than 120 plus bug management and project management tools, also different communication channels, it makes it easier for the tester to directly log in bug from this LambdaTest UI to your bug marking tool. How easy is it to do? As you saw, I just click on mark as bug, it captures the viewport. Just simply mark in the issue, write a text. Let's say it is a bug. You can highlight it, you can underline it, you can mark it at different shapes, and then simply click on mark as bug. As soon as you click on mark as bug, it will give you a pop-up of the integrated tool that you have. In my case, since I have not integrated with any of the bug marking tools, I get by default get the LambdaTest pop-up where I get different fields. And in your case, you'll get all the important fields that you need to fill out before marking a bug. Just simply enter in the assignee, the issue type, priority, for summary, and here you can see that it also has an integration with Microsoft Teams. So since I mentioned that LambdaTest also supports integration with different communication channels, so if you have your LambdaTest account integrated with any of your communication channels, you can also send out this bug directly to the specific channel as well. Once you have all the details entered, simply click on create an issue and this will automatically log a bug onto your bug marking tool. You can see the bug has been marked successfully. And then if you want to share this particular bug or this particular error with someone who's not working inside your organization, but the development team for this is being outsourced and you want to directly share it outside, so you have an option where you can directly click on the share option and share it directly with anyone outside the team as well. Then if you do not have to mark just one screenshot, but you need multiple screenshots or you're continuing testing, so you can directly save these also where you can later mark them all together into one bug. Then the second feature is video recording. Video recording simply, as you can see, let's say if there's an issue that pops up or that comes up only after performing a few actions or a few steps on the particular website, or you want the developer and your tester or your teammate to know how that particular issue or that particular bug can be reproduced, you can record a video to showcase the steps and share that video with the team. The gallery section holds all the screenshots and the videos that you captured. The video, since I just captured, takes a couple of minutes. I'll just relaunch it and you can see the video is also here. Then from the gallery section, you can also select all of the screenshots that you captured while you're performing a testing. And if you want to log them as one single bug, you can simply select the screenshots and create a bug, mark it there again. So I'll not do it again. Then on the fly, let's say if you want to add a Google extension or you want to test out a particular extension, you can simply add in the extension path or the Chrome extension link directly here and click on add. And this allows you to add in or work with the different extensions that you need for your testing in real time. And on the fly, if you want to change the resolution that you want to mark a bug or find an issue on a different resolution, you can change the resolution on the fly as well. Then comes in the IP geolocation. Let's say the website is accessible all around the globe and you want to see how a user from Israel or a different part of the world is able to view the website, and if that particular UI is working as expected, you just simply can search the particular country from where you want to see that. So in this case, I'll simply select Israel and you'll see on the screen that google.com, which was currently showing in English, now has been changed to the particular language based on the location. There is a particular use case where you might want to upload some particular files or TXTs while you're performing the testing. So you can simply do that directly from here, and you can choose the files from your local as well. You just simply click on upload files. It will automatically open up your local directory. You select the file or the document you want to upload and simply click on upload. Then in the settings, we also have a few options where you can change the idle timeout. Idle timeout is basically nothing, but if you're working between multiple um, tabs or multiple things that you're working on and you do not want to come back on LambdaTest and start the session all over again, because in this case the LambdaTest session will time out if left idle in the next 5 minutes. You can increase that timeout by 60 minutes so that even if you're working on multiple things, you can come back and start testing again from wherever you left off. Then you also have an option to change the time zone and your location again, and you also have an option to select the accessibility by choosing the screen reader and everything that you touch.
NVDA speech viewer. NVDA speech viewer. Show speech.
Yep. Screen reader allows you to read all of the options available on the screen. Yep. So after all of these options, using the red icon, you can just simply end the session. And thank you for watching the browser testing session with LambdaTest. In the next video, we'll cover browser testing on emulators and simulators. Hello everyone and welcome to a continuation session on browser testing on LambdaTest. Today we'll talk about how we can perform browser testing on emulators and simulators. Just like desktop browsers, for mobile just click on this mobile icon, which will give you an option to choose between different Android and iOS emulators and simulators. How you can start testing is simply choose the operating system, the device, the browser, enter the URL and click on start. As soon as you click on start, you'll get the emulator launched up for you with the browser open along with the application in it. In this particular browser as well, you can perform actions just like you do on your actual device and work with it. Similar to desktop browser, you get all the similar features here as well. Let's go through them one by one. Mark as bug. Mark as bug again is a one-click bug logging that allows you to capture or take screenshots of the viewport and highlight any of the issues or bugs that you find out while you're performing the testing. Using this bug, you can directly send the screenshot or the issue that you found out by highlighting it to directly onto your project management or bug management tool. As soon as you click on Mark as Bug, a pop-up comes in where you can enter all of the required details just like we did in the previous video, and we can create an issue. This also has an integration with your communication channel, so you can send the particular ticket directly to your communication channel as well. Here in this case, I'm not marking a bug, and then you can also share this directly with anyone outside your team, or you can also download it or save it for later as well. Then you have a video recording option which allows you to record the step-by-step videos of any actions that you perform during your testing. In the gallery, it holds all of the screenshots and videos that you recorded during the session. For videos to appear in the gallery, it takes a couple of minutes. So I'll just close it and reopen it, and you can see that the recorded video is now available. Due to size limitations and API limitations, videos cannot be directly shared into your Jira or into your bug marking tool. However, you have the option to capture multiple screenshots together and mark them all into one single bug. And in this particular device, you also have DevTools option where you can get into the device and capture all of the network logs, session logs, and console logs, etc. You can also rotate the device to check how responsive the application is on a rotated screen. And in the settings, you also have the option to go between idle timeout. That is, if you are currently not working on the LambdaTest screen, but you're juggling between different tasks, but you do not want to lose whatever you tested as of now, so you can increase the idle timeout so that the screen stays to a maximum as it is to in 60 minutes. Then, if you have to test out how your application behaves on different network speeds, you have an option to choose between different network speeds, or even add a custom network speed where you want to test on. Then you can select a different time zone to see how a website behaves in a different time zone. You can also choose a geolocation, that is, if you want to see and how the website behaves when it is being accessed from a different part of the world, you can simply choose a geolocation so that the traffic is being proxied to that country and routed to your system. Then you can also change the keyboard input. That's it. In a very similar way, like we did with Android on Chrome, we can also perform testing on iOS on Chrome, Safari, and Firefox. I hope this session was helpful. Please let me know if you have any questions. Hello everyone and welcome to a quick session on browser testing on real devices on LambdaTest. As you might already know by now, that LambdaTest is the only platform that supports browser testing and app testing on both emulator simulators and real devices. As you can see on the screen, we have both Android and iOS, and let's see how easy we can do perform browser testing on these devices. In case of Android, you can see that we have all the different brands, and inside those brands, we have all different device selections available, along with various different browsers that you can select to test on. And below the device section, there is also a low availability icon available, so which particularly shows that this particular device is currently low in availability. So how you can start to test is simply select the brand, then the device and the browser you want to test on, and click on start. As soon as you click on start, it will locate the device that you selected and open up the browser for you to start testing. As soon as the browser gets opened, we can enter in the URL that we want to test in, and we can begin. In my case, I'll simply enter www.google.com. So you can see, just like a real device, I am now in the Google homepage, and from the left hand side I have the options to mark a bug. So mark a bug is a one-click bug logging that allows you or captures the viewport of the website that you're testing currently and allows you to mark or highlight any issues that you find on that particular viewport. Once you highlight or mark any of the issues or bugs that you find, you can simply click on Mark as Bug, which opens up a pop-up window which shows the integrated product management or bug management tool that you've integrated with LambdaTest. Once the pop-up window comes up, you just need to simply select in all of the uh, important fields that are required for your organization to mark a bug, and in my case, I'll create a demo project, I'll select a bug, and I'll add it as test. Once I've entered all of the important fields, I'll just simply go down and click on create an issue. Also, if my LambdaTest account is integrated with one of the communication channels that I use in the organization, I can also send a bug directly to that as well. So in my case, you can see that my account is integrated with Microsoft Teams, and since I have this checkbox selected, I can directly send this bug that I'm creating right now to my Teams account as well. So once I create a bug, I can also download this particular screenshot or save the screenshot for later as well. I also have an option to record the video so that I can record all the actions or all the steps that I'm performing while I'm doing testing on the application or on the website. Then I have the gallery section, which holds both the videos and screenshots that I record during the session. And I have DevTools option, which allows me to capture all of the elements, the console logs, sources, the network logs, everything for the particular application that I have. I get a geolocation option available. So let's say the application that I'm currently testing is accessible all around the world, and I would like to check how a user from a different part of the world accesses and how the application is working in their area. So let's say in my case, I want to see if I select Israel, how my application behaves. So my application automatically reloads and it appears how it should appear in Israel. Also, I have GPS geolocation. So for applications or for websites which have an embedded map or which have a geolocation facility inside available, so there you can also use set geolocation feature in order to use or check around a particular location. Then we have a home icon to return to the home screen of the device. Then we have device controls where if the application that you're testing has volume, that is has an audio, then you can increase or decrease the volume. Also, you have the option to choose the device language and rotate the device. Also, let's say if in the application while you're testing you want to copy something from the application from this particular device to your local device, for that case, for that scenarios, you also have an option where you can directly copy something from the screen. Just click on copy. As soon as you click on copy, this goes into the device's clipboard, and from that device clipboard, inside the device controls, you have an option to copy that device clipboard and paste this particular value that you've already copied and saved in the device clipboard to your local device. And then in the settings, you also have the option to choose network throttling. That's to check how your application behaves on different network speeds, or if you want to test out how it behaves in a custom speed, that's also available. And you can change the different time zones as well. In a very similar way, you can also test out applications on iOS browsers as well. Hello everyone. Today, let's talk about app testing on LambdaTest. LambdaTest supports app testing on both emulator simulators as well as on real devices. Today, let's talk about emulators and simulators. In case of Android emulators, we need a APK file to be uploaded, and for iOS, we need a .zip file that contains a .app. How you can upload the file is simply click on this upload icon, which will open a native window on your local PC, and from there you can select your .zip or your APK file that will get uploaded and start reflecting under the apps. You can also upload the app by using a direct downloadable URL, and that app would also be represented just like these. Once you have the app uploaded and you want to start the testing, just simply select the APK or the IPA using which you want to start the test, select the device, and simply click on start. Before I start a session, I would also like to take your attention to the three dots in front of each of the applications. The three dots allows you to change the visibility. That is, you can change the visibility between teams or only yourself. You can rename the application or you can delete the APK or IP. Okay. Also, in case of Androids, you also have a toggle button which allows you to select the supported devices. That is, if there's a particular app that you're testing and that is only supported on, let's say, in case of Android, on the latest Android version 13, then the supported devices only toggle will make sure that it only shows device 13. Rest, all of the other devices will automatically get grayed out. To start with, I'm selecting the sample APK and by default selected Samsung device, and I'll click on start. As soon as I click on start, the device that I've selected gets allocated for me, and the application that I've selected is downloaded into that device and installed and open for me so that I can start performing the tests. Here, I can work with this application just like I do it on an actual device. Also, there are a few options that I can work with. On top of the application, if I want to add another application which I would like to test in the same session, I can install a new app, or I can kill the app, or I can uninstall this current app as well. Then here also I have an option to mark a bug. So mark as bug again captures a screenshot of the viewport that you're working on, and you can highlight or try to text to make sure that what is an issue or what is a bug. So let's say I want to write bug, and I would like to underline this or highlight this. So anything, or you can even color this, use different shapes to highlight the issue that you found out while testing, and simply click on mark as bug to send this particular issue directly to your bug marking tool. In my case, since I have not integrated with any of the bug marking tools, I'm getting the default LambdaTest screen, and from here I can simply select the assignee, the issue, priority, and enter in the summary. For each and every different bug marking tools that you might have integrated with LambdaTest, these fields might be different, and all of your important fields should have to be entered before marking a bug. Once you enter all the details, you can just simply click on create an issue. Here you also have a checkbox which shows you that you can also share this particular bug directly to your integrated communication channel with LambdaTest as well. So in my case, it's Microsoft Teams. So I'll simply click on create an issue, and this will automatically log a bug onto my LambdaTest platform itself. Here, I can also share the screenshot directly to anyone outside the team as well if they do not have access to the bug that I've currently marked, or they can also download this or save it for later. Now, here as well, you get a video recording option to record all of the actions that you perform in the particular application. You get a gallery section where you get all of the screenshots and videos that you have recorded, and the screenshots, you can select all the screenshots together and mark them into single bug as well. Then here under DevTools section, you get three different options. First one is the DevTools, which gives you the basic device logs, network logs, app logs, etc., which you can use to debug the application or test. Now, let's talk about UI Inspector. UI Inspector is very similar to what ABM Inspector provides, where you can inspect the elements of the app that you're testing on to write down a code or fetch the elements. Here, you simply need to select the element and you can get the XPaths or the selectors for that particular element. Third is the ADB shell. So the ADB shell supports all the ADB commands to be run on this application. I'll just simply list out all of the ADB commands that we support. Moving forward, we provide you also a few device level controls. That is, you can change the keyboard language, you can rotate the device, you can lock the screen, increase the volume, decrease the volume, and if the application that you're testing responds to shake feature or has an action that it performs when you shake the device, you can also trigger the shake action as well. Then we provide both IP-based geolocation and GPS geolocation. So in IP-based geolocation, let's say the application is accessible across the globe and you want to see how the traffic on the application responds while you're accessing it from a different country or a different region, you can choose the IP-based geolocation. However, for applications that has an embedded map or that uses a GPS geolocation like Uber or Swiggy, you can use GPS geolocation to set the particular geolocation you want to test the application on and choose between the different locations. Going to settings, you have an option to choose between idle timeout so that if you leave the system idle, it doesn't switch off. Then you have network throttling, where if you want to test out your application on different speeds or a custom speed, you can test that out by entering the custom speeds and the custom upload speed, download speed, and latency. This was a quick overview about application testing or app testing on Android emulator. In a very similar way, we also support application testing on iOS simulators as well. Hello everyone and welcome to a quick session on app testing on LambdaTest real devices. LambdaTest provides you a wide variety of real devices under both Android as well as iOS. In order to test your Android applications, you need a .apk file or a .aab file to be uploaded, and in order to test your iOS, you need a .ipa file to be uploaded. How you can upload it is by simply clicking on this upload icon, which will open up your native uh, device screen or desktop screen, from where you can select the IPA or APK depending on what you want to test out, or you can also select on this URL icon where you can directly enter in a download URL and upload the APK or IPA that you want to test out. Also, in case of Androids, there's another feature called show supported devices only. So let's say you want to test out a particular application, but it's not working on a particular device. So you can enable this toggle and click on this device, which will which will in turn let you know that the particular application that has been selected is not supported on this particular operating system. So you can see that all of the devices that is currently on Android 12 are not supported, which means the application is not built to support on this particular version. Other than that, in front of this particular application that you upload, you'll also get three dots, which will allow you to choose or change the visibility. That is, if you want to share this APK only with yourself, or you can share it with the complete team, or you can rename the APK. So if it is, let's say for a staging application, you are uploading staging version 1, staging version 2, and you want the same way it to be represented here, you can rename the application. If you can delete it if it's no longer required, and you can also copy the app ID so that you can use it for automation testing purposes. Yep. Moving forward, since these are actual real devices, the sessions can also be directly launched from a Play Store, App Store, or even from TestFlight or App Center. So instead of uploading an APK, if you want to test out an application that rests in a Play Store, you directly can select Play Store and launch a device. So how easy is it to start the test once uploaded? You need to simply select the APK or IPA that you want to test, click on the device you want to run the test on. So I'll select iPhone SE 2022 and simply click on start. As soon as you click on start, the device that you selected particularly gets allocated for you. And as soon as the device is located, the application that you selected gets downloaded into the device, gets installed, and is open for you so that you can start testing here. So you can see on my screen that an app called My Diary has been opened. And just like you do on your real device, I can simply scroll through the application, I can work with the application, or I can perform different actions. And other than that, on the left hand side, you can see there are a few different options that are available. The first one, so let's say if you have an APK or if you have a secondary application that you want to upload and you want to test on, so you can simply click on install new app and you can also install that application as well. If you want to kill the particular application that you're testing, you can simply click on kill app. And if you want to uninstall the application, you can do that as well. Then you have mark as bug option. So mark as bug is a one-click bug logging that allows you to mark any bugs or any anomalies or issues that you find on the application while you're testing it out. Mark as bug automatically captures the screenshot of the viewport that you're testing on, and along with the details or the information of the device and its operating system it's running on, and you can directly mark this into your bug marking tool. So in my case, on my account, since I have Jira integrated, so it will automatically open a pop-up with the Jira details that are required for me. So I'll create this bug in a demo project. I'll assign it to myself, and I'll keep the issue as stub bug. And yeah, so just like this, you can also enter all the required details in your bug marking tool and simply create a bug. And if you've also integrated your LambdaTest account with one of your communication channels, let's say Microsoft Teams, Slack, so you can also send this bug directly to that integrated channel as well. Once all of the instructions, all of the details and instructions are filled in, just click on create an issue. In a few seconds, it will automatically create a bug into your Jira account. And even you can download this particular screenshot to your local machine, or you can save it if you're continuing testing and you want to access it later. Then you also have a video recording option where you can record all of the steps that you're performing while you're performing the steps or you're taking an action. And the video recording also helps when a bug that only appears after so few precise clicks that you're performing on the application or few pages that you're traversing through. So in order to share those precise steps to your team, you can record a video and share that within the team. Then we have a gallery section. So gallery section holds the screenshots as well as the videos that we recorded during the session. And then we have developer tools. So in the developer tools, basically it gives you all of the device logs, the app logs, the network logs, etc. of the application that you're currently using. So if you want to analyze or if you want to debug the application, if let's say one of the APIs is not working or one of the network logs is API response is not coming as expected, you can use the debug option to check all of those logs. Then here you have a geolocation option available. So let's say this particular application that I'm using, can be accessed all across the globe, and I want to check how my application behaves when I'm accessing it from a different part of the world. So in order to do that, I can simply click on select a country, and I can choose a separate country where the app is accessible, and I can check how my app behaves if it has a different behavior in that part of the region. In case of my app, since it behaves similarly, so the similar app opened up. And we also have a GPS geolocation, that is for applications like Uber or Swiggy that requires a particular set geolocation so that it tracks the traffic and tracks the shops around that particular area, or gives you a cab according to the particular area you have selected. So for that particular option, we also have a GPS geolocation that you can set here, or you can also drag this pin to set the GPS geolocation, and you can use that as well. Then we have a home icon, so that if you want to click on the home screen to test out how the application behaves, you have a home icon to do that. Then we have a few device controls, where if you want to rotate the device to see how the app behaves while the device is rotated, you can check that. And you can also have the option to control the device language as well. Then in settings, you have the option to set the network throttling, that is how fast or how slow the internet traffic would be, and pertaining to that particular internet traffic, how your website behaves. You also have an option to set a custom profile, that is if you want to test out how the application behaves in a particular download, upload, and latency, you have the option to do that as well. Similarly, in a very similar fashion, you also have an option to test out APKs, that is Android based applications, and which will have all of the similar options available. Today, let's talk about browser automation on LambdaTest. LambdaTest supports browser automation on desktops, emulator simulators, as well as on real devices. The screen that you see is the automation dashboard, where you get all of your tests and builds landed down here. How, before I explain or go through this particular UI and how we reach up till here, let's get into the code base section. So here I have a very basic test case written, where I'm simply opening up a URL, performing a few actions, driver waits, performing a few clicks, and that's it. So any of your test case on any of your web applications that you might be currently running on your local browser, or on a cloud infrastructure, or on a remote grid, you can very easily translate those tests onto Lambda test, and it's a simple two-step process. The first step is you need a Lambda test username, access key, and a hub URL. Now, the LambdaTest hub URL is an address to the LambdaTest grid, under which you get all the device selections or all the browsers, and the username and access key is to authenticate yourself as a user on the platform. From where you can get these three is from the LambdaTest UI itself. Under the access key option, just click and you'll get the hub, the username, and access key rightly from here. Once you have all these options, then you need the LambdaTest capabilities. So capabilities are nothing but instructions that you provide the LambdaTest script as to what particular browser, operating system you want to run the test on, what particular version, what are all the different types of logs you want, and so forth. How you can create a capability object specific to LambdaTest is by using the LambdaTest capability generator. Just simply click on this question mark icon just besides the access key. Here, just click on the capability generator. Since LambdaTest is language agnostic, that is any language or any framework that you have your test case on, we can run it on our devices. So based on the language or framework you have, you can simply select the language and select the framework. In my case, it's Java, so I'm leaving it as is. And then you can select if it's a Selenium test case or an APM test case. That is, if you want to run it on a desktop browser or mobile browser, and you can select the different sets of capabilities. So in my case, if I select Edge, and then a different version. And then if I click on advanced, I click on the operating system I want to run on. If I want a particular resolution, a Selenium version, and to have pop-ups, I want to run it on Selenium CDP. So all of these can be selected. There are different types of capabilities that we support, like the build name, different test tags that you can add. Uh, you can also record screenshots or capture screenshots for every command, record a video. You can test out your local applications by using a tunnel. For that, you just need to pass in tunnels as a capability. So all of those capabilities, whatever we support, you can easily get it from this capability generator documentation. Once you have the capability object from the capability generator, simply copy it from there and paste it here. And once you have the capabilities and the username, access key, and the hub URL, you just need to create a remote WebDriver connection which will interact with LambdaTest. So here in this case, I have my username, access key, the hub URL, and the capabilities, which in turn is creating a remote WebDriver connection to my LambdaTest script. So since I have all of these, I can simply start my test case. Before I start my test case, I would also like to highlight that since I'm using a Java TestNG project, I am configuring the desktop browser and versions in an XML file, and from this particular XML file, all of these are getting triggered to my platform. So in my case, I have 4 different browsers that I've selected. So and here, since I have all of that, I just simply run. In a couple of seconds, while the test is getting initiated here, you'll also see the test getting landed on the LambdaTest platform. Let me quickly refresh to check. Yep, as you can see, I have 4 different uh, browser combinations that now are running, and they all are running parallelly. So on LambdaTest, you can run your automation test cases parallelly depending on the number of parallel connections you have with LambdaTest. So in my case, I have around 310 parallels, which means that at a single instance of time, I can run 310 test cases on different OS browser combinations. On LambdaTest, we also provide you a feature called live interaction, where you have the ability to get the access of the browser where your test is currently running and perform actions manually, which will help you debug or understand if there are any pertaining issues that you're working on. So in this case, I have the access to this current browser, where if you want to choose this, or I want to get into the network logs, I can interact with this browser and get all of those details. Now, as I was talking earlier, this is the build view where you get all of the builds that you ran on the LambdaTest platform, and you can search or filter out the builds based on the test name from the search bar. Once you have the build, inside those build, you have all the test cases that were executed in that particular build, along with its browser version, the windows, and the time that it took to execute. Also along with the status as well. So LambdaTest by default marks the test cases as completed, and in order to mark those test cases as failed or passed, we have our LambdaTest hooks, which you can use to mark your test cases as failed or passed based on your test cases. Then getting into the test case, you'll get a full-fledged detailed view of all of the test execution. On the top, you can see the status that the test has been passed. Then you have the test name along with the test ID, and on the right hand side, you have the configuration where the test run on along with the time. Below it, you have a complete execution video of that particular test that ran, and which will get started in a moment. Yeah. And below it, you have the basic info like who ran the test, how much time it took, what was the Selenium version it ran on. Input config basically gives you the details of all the capabilities that you used while running the test. Then the video gives you the complete video and the screenshots. Then you have the command logs here. So the command logs are basically synced with the video. So if in case you're particularly debugging and there's an error on a particular command, you can directly click on that command so the video automatically aligns to that particular moment and it is synced with the video. Then you also have the network logs. Network logs are basically all of the network requests that are getting captured during your test execution. Other than that, you also have few Selenium logs, the raw Selenium logs, the browser console logs that kept captured, and the terminal logs as well. Out of these, the network logs, the browser console logs, and terminal logs, everything can be controlled using capabilities, which means that if you do not require these logs, you can pass the capability as false and these logs won't be captured. LambdaTest also captures screenshot of each and every command that you're running. So with each and every command that you're running, you also get a screenshot of the command when it gets executed. So this was all about browser testing on LambdaTest. However, when we talk about testing or automation testing, you might also be concerned about reporting. So with LambdaTest, you also get an option to create complete reporting using our APIs. So whatever you see on the LambdaTest dashboard, that is the logs, the video, screenshots, you can fetch everything using these APIs and you can use it on your site to build a reporting based on whatever data you need. Welcome to a continuation session on web testing on LambdaTest. In our previous video, we talked about web automation testing on desktop browsers. But as mentioned, we support automation testing on desktop browsers as well as on mobile browsers. Today, let's talk about how easy we can perform or run our web automation test cases on real device browsers or on emulator simulators. What you see on the screen is the automation dashboard where all of your test cases get landed up once you execute your test cases from your script. Before getting into the dashboard, let's see how easy is it to send our test cases onto LambdaTest. Here, what you see on my screen is a basic code where I'm just opening up a website, clicking on a few items and making a few actions. In similar manner, if you have any code of your web application that is written in any language, you just need to add two steps before so that you can send out your test cases to LambdaTest. So let's talk about those two transition steps. The first one is you need a LambdaTest username, access key, and a hub URL in order to send your test cases to LambdaTest. From where you can get this information is from the automation dashboard itself. So on the automation dashboard, you have an option called access key. Under the access key, you'll get the username, the access key, as well as the hub URL. Once you have these, then you need to instruct the LambdaTest grid or inform the LambdaTest grid as to what particular device or browser or version you want to execute or run your tests on. For that, we have an option called capabilities. And from where you can generate these capabilities is from an intuitive document that we have, we like to call as a capability generator. You can open the capability generator directly from the automation dashboard by clicking on this question mark icon and click on capability generator. I have it already open, so I'll quickly jump on to the capability generator. Based on your language and framework, you can choose the drop down to select between the languages and the frameworks that you're working on. Then click on APM since we are talking about mobile browser testing. Once you click on APM, you'll get the options to choose between Android and iOS. Just click on Android and iOS and you can choose the devices on which you want to run the test cases on. Once you make the selection, on the right hand side, you can see that a capability object is automatically created, and you can simply copy this and use in your code base. This capability that you see here, which shows real device, before talking about it, I would like to again highlight the LambdaTest is the only platform that currently allows you to run your test cases on both emulator simulators as well as on real devices. So to bifurcate between both, we have a capability called real device, which if you toggle it on, you'll get a new capability added in your capability object called is real mobile true, which will make sure that any of the test cases that you're running are only landed up on a real device instead of an emulator or a simulator. So going back to the code base. So here, as you can already see, that I already have a capability object created, and once I have the username access key hub URL and the capability, I just need to create a remote WebDriver connection. So the remote WebDriver connection includes my hub URL, which includes my username, access key, as well as the LambdaTest grid URL, which is hub.lambdatest.com, and the capabilities. I'll show you the difference that you'll have to make in your code in order to run or trigger your test cases onto a real device or an emulator simulator. For now, in my case, currently my tests will be getting triggered and will be run on an emulator or a simulator. Since I'm using a Java test ng, I'm fetching the values, that is the capabilities, dynamically from an XML file. And in the XML file, I've already mentioned the device, its platform, and the platform version where I want to run the test cases on. So as you can see, I'm running one of my test cases on an iOS device and the second one on an Android device. So I'll go back to my code section and simply run this. As soon as I run my test case, in a few seconds, as soon as the processing is done, the test case will automatically land up on the LambdaTest automation dashboard. If I scroll here, so you can see a new build here has landed up called demo emulator. And as soon as I click on this demo emulator, as you can see, one of the test cases has already landed up, and this is because I have a thread count set in my code which says 1. So only after one execution it will send the second. But on LambdaTest, you also have the provision to run test cases parallelly. That is, you can run both of these executions together without waiting for one to complete. Here, as we were talking about, this is all the build view. That is my build, which I need demo emulator, has landed here. And inside that build, I get the view of all of the test cases that I ran. In my case, since I only ran 2 test cases, I'll go into one of them. Inside this test case, you can see I'll get the status, I'll get the test name, the test ID, as well as here the device on which the test ran on. Then here I'll get the complete execution video of the test along with the complete command logs as well. At the bottom of the video, I'll also get basic info, which includes who ran the test and what duration it took to execute the test, and also the input config, which gives you all of the capabilities that you passed while running the test. Also, you'll get the video as well. Then we also provide you the network logs and the APM logs, console logs, and terminal logs as well. The network logs currently are not appearing because in my code base, I passed the capability as network true as false. So the network log, console logs, and the screenshots that we capture on each and every command, all of those can be controlled using our LambdaTest capabilities. Also, for this particular test case, if you want to share it directly to any of your team members or outside, you can directly use a shareable link to share it. Also, if let's say this is an issue and you want to raise it to one of your developers or one of your team, you can simply click on create an issue, and this will automatically open up the one-click bug logging where you can directly log a bug to your bug marking tool and send it to your communication channel as well. So here the test case has been executed, and if I go back to the build view, you can see both of my test case, one on a Galaxy S20 that's an Android, and the other one on an iPhone has been executed and passed. Now, as I was talking about in the beginning, that we support both emulator simulators as well as real devices. So as shown on the capability generator, we need to add in a capability on the code side, which is real mobile true, so that it picks up the inventory from the real mobile. And the one different other change that you have to make in order to execute your test cases on a real mobile is that the hub URL in case of real mobile would be mobilehub.lambdatest.com. I'll repeat this point once again. For executing your test cases on emulators and simulators, you do not have to use any additional capability. You just need, and the hub URL would be hub.lambdatest.com. However, whenever you want to execute any of your test cases on real mobile browsers or real devices, you'll have to add a capability called is real mobile true and also use the hub URL mobilehub.lambdatest.com. I hope this session was helpful. In case you have any questions, please feel free to reach out to LambdaTest support or support@lambdatest.com. Hello everyone. Today let's talk about app automation on LambdaTest. LambdaTest supports running your native app test cases on both iOS and Android devices. This that you see on the screen is the LambdaTest app automation dashboard, where you get the details of each and every test cases that you run. Before we discuss about the dashboard, let's get into how we reach here. Opening my code base, I have a very basic script of where I'm opening up an application and I'm performing a few clicks, entering a few data, and that's it. In the same manner, you might also have a script for your iOS or Android based application, but you might be currently testing on your local device, or you might be testing on a cloud grid, which you can easily transition to LambdaTest. Any test case that you currently have can be transitioned to LambdaTest with just 2 steps. The first step is you need a LambdaTest username and access key. Basically, to authenticate yourself as a user on the LambdaTest platform, you need the credentials, and how you can get these credentials is from the automation dashboard. Just click on the key icon, under which you'll get both the username, access key, as well as the hub URL. Once you have the credentials, then you need the set of capabilities. Capabilities are basically nothing but the instructions that you provide the LambdaTest grid as to what particular device, platform you want to run your tests on. From where you can generate these capabilities is from an intuitive page we like to call as capability generator. So from the capability generator, you can choose the capabilities based on your language under which you already have your code setup running. So in my case, since I have Java, I'll select Java, I'll click on APM, and it'll automatically give me the different device choices. Since LambdaTest only supports app automation on real devices, you'll have to make sure that whenever you're running your app automation test cases, you have the real device toggle on, which will in turn return your capability, which is called is real mobile true. Once you have that, then based on your application, if it's Android or iOS, just make the selection and choose a device that you want to run the test on along with its version. Once you've selected the device, then you need an app URL which tells the LambdaTest grid as to you want to run all of the test scripts that are written below on this particular app. But how do you get this app URL? To get this app URL, you can simply go onto the LambdaTest automation dashboard, click on app upload, click on browse file, which will automatically open a native window on your desktop, and select the APK or IPA you want to run the test on. And as soon as you select this, the app gets uploaded on one of the secure locations behind your username and access key, and it will return you an app URL which you can use in the capability section. Once, as you can see, the app is now uploaded, and now you can copy this particular app URL which you can use in the capability section. And that is it. You have all the capabilities you need to run. Since in my code base I've already set the capabilities, I've already configured them, I'll not be changing those. And also, if let's say you want logs, that is the network logs, the device logs, the screenshots for each and every steps that are running, or the console logs, you can control those by the capabilities as well. Once you have the username access key and the capabilities, you simply need to create a remote WebDriver connection, which includes your username, your access key, hub URL. In case of LambdaTest real devices, the address of the hub URL would be mobilehub.lambdatest.com, along with the capabilities. Once you have all this and the script is down there, the only thing you need to do is just right click and run the test. Now, as soon as I go to the app automation dashboard, here on the app automation dashboard, as you can see, no builds have landed, which means the test that I have ran has now landed here. I'll quickly refresh the page, and you can see the demo Android that I just ran has now landed here. This particular screen shows all of the builds that you ran while executing a test case on LambdaTest. I'll click on it, and this will give you the detail of the test that is currently getting executed. Here on the left hand side, it gives you the details of the test device that it's got executed along with its version. On the right hand side, it gives you the execution video. I'll quickly refresh it once. Yeah. On the right hand side, it gives you the complete execution video of the test case that it just executed, and below it, it gives you the details of the app info, the capabilities that you selected, along with the screenshots that got captured. And here in the middle, it gives you each and every command that got executed. And if you select this visual checkbox, it will also show you the screenshots that got captured, which are saved here as well. Then it will also give you the network logs that you captured, the device logs, as well as the APM logs. As mentioned, the APM logs, device logs, network logs, as well as the visual logs, that is the screenshots, all of these can be controlled using capabilities. Also, this particular test, if you want to share it directly with someone in your team or outside, you also have an option where you can directly share this by simply entering in their email address, and they can directly view the complete execution of a particular test. In a very similar way, since we executed the test for Android, in a very similar way, you can also execute the test case for iOS as well. In my case, since I executed it with Java, here if I go, no, I went to the wrong screen. Yeah, here if I go, you'll get a complete sample of the test that I just executed, and along with that, you'll also get the APKs and IPAs. So since the test that I executed was Android, you can also execute iOS test as well. I hope the session for app automation on LambdaTest was helpful. If in case you have any questions related to any of the topics on LambdaTest, feel free to reach out to LambdaTest chat support or reach out to support@lambdatest.com.
Welcome. With continuous growth in the market for mobile devices, businesses are consistently developing strategies to create user-friendly websites. To achieve this, they use mobile-first design, progressive web apps, single-page applications, and more. However, for a unified user experience across devices and platforms, we need to consider different screen resolutions and device capabilities, and this is where responsiveness comes in. To help you develop and debug such responsive websites, LambdaTest has been cooking this behemoth of a browser. You must have heard about LT Browser. Well, buckle up as we announce the all-new and blazing fast version of it, the LT Browser 2.0. LT Browser 2.0 is a Chromium-based developer browser that allows you to develop, debug, and build mobile websites and web applications faster than ever. We'll get into that in a minute. In this video tutorial, we'll go through all the features of LT Browser 2.0 and how you can use them to take your mobile view debugging to the next level. So let's dive in. To get started, make sure you have the LT Browser 2.0 downloaded on your desktop. You can find the link to download it in the video description below. Once you log in, type in the URL you'd like to test. What really sets LT Browser 2.0 apart from a regular browser is its ability to view your mobile website on multiple device viewports simultaneously. From the left, you can search or choose a variety of mobile, tablet, and desktop device viewports. Simply select the device from the drop-down to view your mobile website on. You can also favorite any device by clicking on the star icon in the top right corner. You'll find your star devices under the Favorite Devices tab for quick access. LT Browser 2.0 lets you interact and debug with up to 4 devices simultaneously. To add more devices, click on the Add Devices button in the top right corner. Now you will be presented with a plethora of devices to choose from. You can search for devices, select from separate device categories, and even create unlimited custom device viewports. To create a custom device viewport, simply add the required specifications. For this tutorial, we have created a custom desktop. As I mentioned earlier, LT Browser 2.0 is based on the native Chromium engine called Blink. This means that you can now easily access all the regular Chrome settings and features, such as installing Chrome extensions, using Chrome settings and APIs, having access to the latest and faster Chrome dev tools, experiencing better memory management, unlimited tabs options, and more. You can also customize LT Browser 2.0 as per your preferences by heading to the browser settings. LT Browser 2.0 offers loads of features to help you debug your website effectively. Let's go through them one by one. LT Browser 2.0 will mirror all your interactions made over one device onto the other. That means every scroll, click, and text specification action over one device is automatically cloned on another. Now there may be instances where you would want to turn off the device sync option. For example, the difference in viewports or when screen resolution is too big. That's when you would have to turn off the device sync. To do that, simply head to the settings and turn the toggle off for the device sync option. If you encounter any bug on your website, LT Browser 2.0 lets you capture a screenshot of your website. To do so, you just need to click on the camera icon, and that's it. You can either capture a screenshot of a viewable area or generate a full-page screenshot of a website. To capture a full-page screenshot, simply head to the settings and turn on the full-page screenshot toggle. And the next time you click on the camera icon, a full-page screenshot will be generated. After capturing a screenshot, you can easily highlight the bug using the toolbar on the left, different shapes and colors. And even add a note. Click on the Mark as Bug option. LT Browser 2.0 allows you to integrate LambdaTest with your favorite project management, bug tracking, or instant messaging tool. That way, when you mark a bug on LambdaTest, it will automatically be shared with your projects or workspace so your colleagues can access it. You can then fill in the details of your bug, set a priority, assign it to a member of your team, and send it directly to your integrated platform by clicking on the Create Issue button. LT Browser 2.0 allows instant sharing by clicking on the share icon and entering the details. You can also copy the generated link and share it with your teammates quickly. You can even download the edited image or save it in the browser media for future use. Want to ensure that your website is responsive in different device orientations? Simply click on the rotate icon to switch to the landscape mode of the device. Click on the icon again to return to the vertical orientation. To help you debug your website on the go, you can access the inbuilt developer tools by clicking on the debug icon. LT Browser 2.0 allows faster debugging by offering dedicated dev tools for every device viewport. If you ever come across any bug which is either too complex to reproduce, you can easily record your test sessions by clicking the video button. Unlike its predecessor, LT Browser 2.0 offers multiple video recording options. You can now record the full screen or a particular tab with the latest version. As you can see, the video has started recording. You can find your recently recorded video inside the Media tab, which acts as a gallery where you will find all your captured screenshots and recorded videos. If you want to share any of these, just select all and share them, or you can even share them individually. LT Browser 2.0 also allows you to test the responsiveness of a website in different network conditions. You can test your website on different network speeds and see how your website looks or behaves at these variable speeds. With the LT Browser 2.0, you can perform a usability test on slow networks and debug on the go. Network throttling allows you to see how your website behaves when offline or on 3G or 4G network speeds. You can simulate the network conditions with a single click and check how your website performs under different network conditions. Speaking of performance, LT Browser 2.0 allows you to generate a performance report of your website in just a single click. This performance report is powered by Google Lighthouse. You can find different performance metrics to help you analyze and improve your website or web app's performance. Like the Mark as a Bug feature, you can share this performance report with your colleagues using the share button. You can do that by either entering the email ID or by creating a shareable link. LT Browser 2.0 also supports hot reloading. Like a regular Chrome browser, you can go back and forth using the navigation arrows, refresh the web page, and leverage the keyboard shortcuts with the LT Browser 2.0. You can find the list of all active keyboard shortcuts under the Help tab. We also have a step-by-step guide to help you get started with LT Browser 2.0. We're already working on the next set of features for LT Browser 2.0 to help developers build mobile web apps faster and better. Meanwhile, we look forward to receiving your precious feedback. Give it a shot and let us know.
So in LambdaTest, we basically offer a pixel-to-pixel comparison of different screenshots that you want to compare. So you can compare a baseline image, which according to you is the ideal image of your website. And then you can take comparison images of different environments or different OS browser combination, and then compare them using our visual regression product. Now, we do support all the programming languages and the frameworks that Selenium does. So you can use any existing setup that you have, and simply by adding few steps, you can do visual regression test in your existing suites. So to start with, this is how our visual regression dashboard would look like. So I'll break this demo in two parts. The part one would be the backend part from where I'll be running the test, and part two would be this UI where our automation test would be reflecting. Right, so to begin with, the first step would be to create a new project in our visual regression dashboard. So I'll click on new project, and then in here I can define which product I want my test to show in. So I'll type visual UI demo. And then from the number of users in my account, I can select the approvers. So these approvers would have the authority to either approve a comparison, or if they feel that the mismatch percent between the two screenshots is too much, they can mark it as a bug. So you can select up to 5 approvers from the account. And at the end of each visual regression test, they would get an email regarding the comparison and a reproducible link to the LambdaTest dashboard. And finally, we also have this tags option. So depending on your requirement, you can select any particular date or any particular tag. So this would help you in segregation or filtering purpose of your visual regression project. So I'll click on create project, and this would create an empty project on my dashboard. So it would look like something like this, visual UI.demo. And since we haven't run any test in this project right now, so it would show 0 builds. Now, for the programming side, I have a basic setup in Java. So any programming language or framework, the integration of LambdaTest would be a basically 3-step process. The step 1 would be the LambdaTest username and the access key. So in here, I have defined them in the environment variables. However, you can also pass them as a string directly as well. On the dashboard, you can click on this access key icon to fetch your LambdaTest username and the access key. Now, the second part would be the set of capabilities on which you want to run the test. So for this test, I have defined Windows 10 Chrome latest, but depending on your requirement, you can select a different configuration as well. On the LambdaTest platform, you can go in the LambdaTest capability generator. So in here, we have all the latest OSs and browsers available. So depending on your requirement, you can select any configuration on the left side of the screen, and the respective code is generated on the right part of the screen. So you simply need to copy paste these script in your code, and the test would run on that particular configuration. And finally, the third step of the integration would be to point the test towards LambdaTest Selenium grid using this remote driver and beta smart UI.hub. So these were the 3 steps you need to add in your script instead of your local driver to point the test towards LambdaTest Selenium grid. Now, what makes this visual regression smart are some of these smart UI options that LambdaTest gives. Now, these options are configurable from the code level and also from the UI level as well. So I'll briefly explain these smart UI options. So the first one is the error color. So whenever 2 screenshots are compared, the difference between those screenshots is highlighted. So using this RGB combination, red, green, and blue, you can decide that color. So let's say if the screenshots that are being compared are blue in color, then it would make more sense if the difference is highlighted in a green or a red color. Then the next one would be transparency. So transparency value ranges from 0 to 1. So if you set the transparency to 0, it would only show the difference between the screenshots. And if you set it to 1, then it would show the difference along with both the images in the background. So it would be like an overlapped image with the baseline image, the comparison image, and the resultant image. Now next is this large image threshold. So this is the sensitivity of the comparison. So more is this value, more is the accurate comparison between the screenshots. And the value ranges from 100 to 1200. So if you set the value to 1200, it is the most accurate comparison that can happen between the images. And then we offer this capability called box. So using this box, we can put some custom pixel values, and that would create a box structure in our screenshot. And then if you put that box in the bounding box capability, that particular box would be compared between the 2 screenshots. And if you set it in the ignored box capability, that particular screenshot, that particular box would be ignored while calculating the mismatch percent. So as a use case, let's say there is a banner that you want to ignore in the comparison. So you can create that box using this pixel value and then pass it in the ignored box capability, and that particular banner would be ignored while calculating the mismatch percent. Now next, let's say the comparison image is of a different sized one than the baseline. So in that case, you can put this scale to same size as 2. So it would automatically change it to the same size as the baseline image and then starts doing the comparison for more accurate results. So these were some of the smart UI options. Now for this demo, what I'm doing is, first of all, I'm opening this LambdaTest I'm using this driver.get.amazon.in. So I'm opening Amazon website, and then I'm using this webhook to capture the screenshot of the home page. Right. And also to make sure that all my projects are going to the new project that I created. So I have mentioned the project name here, Visual UI.demo, which we created initially. Now I'll run the first test. Okay, right. So by default, the first test in any particular project is considered as the baseline image, right? And since it is the baseline, it would be automatically approved because it has nothing to compare it with as of yet. Now, the next thing what I'll do is, while this is being captured, the next thing that I'll do is, in the code, I'm after opening the Amazon website, I'm putting a sleep of 5 seconds. So it would open the website, then wait for 5 seconds, and then capture the screenshot. So basically, Amazon website has few banners that keep on moving. So after 5 seconds, there would be a different banner on the screen. Hence, the screenshot would look different. Right. So let's say if the previous test was completed, yes, it was. So that screenshot is approved since it was the baseline. Now I'll run the same test script again with a 5 second sleep. Okay, so we have the second screenshot already here, and it would take a moment, approximately 5 more seconds, to capture the screenshot of this second page. And once it is here, it would start doing pixel to pixel comparison between the images. And if there is a slight font change or pixel color change between the screenshots, it would be highlighted using the error color that we have defined in our script. Right, so it says it is captured and it says one change is found. I'll open the second build. Now on the left side, what we have is the baseline image. On the center, we have the comparison image, and on the rightmost, we have the resultant image. Right, so the banner that you see in the background that moved in the comparison image, which shows this major changes in the screenshots. Now I'll click on this horizontal mode to see the difference in mode details, and also I can click on this difference mode. So this would allow me to use this toggle button to see both the baseline and comparison in real time and spot the actual differences. Right, along with that, in the vertical mode, you will also see the mismatch percent of the screenshots. So as a tester, if you feel that 0.28.25 is considerable or approvable, so you can click on this approve button, and that would approve the comparison image. But if you feel that 28.25 is too much, in that case you can click on this report bug icon, and it would call the API of whatever bug tracking tool you have integrated with. So my account is integrated with Jira, so I can directly push the resultant image from here itself instead of separately going to Jira to create the bug. Right. Along with that, we offer some additional settings as well. So as I mentioned in the code, the smart UI options that we were controlling from the code level, so that can also be configured from the UI level as well. Right. So all the changes, I mean, if you want to add approvers later in your project, or if you want to change the sensitivity of comparison or change the error highlight color, right? So you can do it from the project settings. Along with that, one of the new features that we have introduced is the custom mismatch percent. So let's say I set the mismatch percent to 14. So any comparison in which the mismatch percent is less than 14, those images will be automatically approved. And if it is more than 14.6, then only you will get the option to either approve it or mark it as a bug. So let's say you are comparing 100 to 200 images at a time. So this feature would be quite handy in those scenarios. Now, as I mentioned, the first build in any project is considered as the baseline image, right? However, the users also have the option to make a later build as the baseline. So if I click on this make a baseline option, the second build would be considered as the baseline now. So going further, any next build would be compared to this one instead of the first one. And also this is also configurable from the code level as well. So in the code, you can pass this capability smartui.baseline. So it would make any new build as the baseline build, and then compare the next consecutive builds with this one instead of the first one. So this was the visual regression project. So if you guys have any questions, feel free to email us at support@lambdatest.com, and we'll be more than happy to help. Along with that, we also have documentation available here on the Lambda test dashboard. So you can simply add the steps like adding the beta hub and the Lambda test username and access key, and use your existing Selenium projects to run the test on the visual regression dashboard. Right. Also, if you want to capture the full page screenshot, so for that we also have the capability called smartui.fullPage take screenshot. So that would capture the screenshot of the full page instead of just the viewports. Along with that, we also have support for Cypress in visual regression. So if you are using Cypress, then also you can do your visual regression test on the Lambda test platform.
Screenshot testing is a feature that LambdaTest provides, which allows you to capture 25 screenshots on different OS browser as well as devices. On LambdaTest, you can simply come on the Screenshot Testing tab, enter in the URL of which you want to capture the screenshot, select the operating system and browser under which you want the screenshots to be captured. I'll select a few in random from both devices as well as desktops, and a few devices. And once you have made your selection, that is, you can see here, I have 7 combinations selected, 3 desktops, 4 devices. Simply click on capture. As soon as you click on capture, it reverts you to a different screen where the screenshot process has started. In the meantime, it's capturing the screenshots. I'd also like you to go through the rest of the features. LambdaTest also provides you a capability to create 3 lists of 25 each. So let's say in your organization, you have most commonly used operating system and browsers based on your customer data. So you can create a list according to the data that you've captured and create 3 separate lists, 25 each, and use those lists to capture the screenshots accordingly. Screenshot testing, you can also schedule it based on your deployments or changes that are being happened on your web application. So you can schedule these screenshots based on weekly, monthly, or daily, and whenever you execute these scheduled screenshots, you'll automatically get an email post the screenshot completion on the selected OS browser combinations. You can also capture screenshot of website which is behind a basic authentication. That is, you simply need to enter in the username and password of the uh, website that has a basic auth. Simply click on save, enter the URL of which you want to capture the screenshot, and click on capture. Also, if you have a web page that is behind a login and you want to capture the screenshot of the um, first page after login, that also is possible by creating a login profile on LambdaTest. LambdaTest allows by default for you to create 5 different login profiles. And how you can create a login profile is I simply edit this one. So here in this case, you need to enter in the URL of the login page. In the next page, you need to enter in the locators of the elements, that is the email, the password, as well as the button on your screen. And then in the next page, you need to enter the credentials and save it with any name that you would like. Once you save this, you simply need to go to login, select the profile that you want to use, and enter in the URL of the page that you want to capture the screenshot of. Once that's done, it will automatically capture the screenshot of this page. And how that does is, as soon as you click on capture, it first logs you in using the profile that you have saved, and then travels to this page that you have, or this URL that you have put here, and then starts the screenshot process. Then in the settings, you also have a few options where if you want the quality of the screenshot as original or compressed, you can do that. For mobile, if you want portrait or landscape, you can do that. Then there are a few websites which might take a few seconds to load up, and if the screenshot process starts before the web page loads up, the screenshot might not be correct. So for those cases, you have an option to use the defer time. What it does is basically it stops the screenshot process for the selected time and only starts it after the time that you've given here. You can also choose between different resolutions for Mac and Windows, and here also you have an option for default location. So let's say if the application that you're currently testing, you want to test it and you want to capture the screenshot of that application from a different country or region, you can simply select the country from where you want to capture the screenshots and you can add it here. And also you have an option to get the email on completion. That is, for every screenshot that you execute, if you want an email to be auto generated and send you the screenshot results, you can get that as well. So here, let's go to the recent tab and go here. And as you can see, the screenshots are getting captured, and I'll open one of them for you. So this is how the 𝐼𝐞𝐻 website would look on an iPhone 13 Pro Max, iOS 15. Similarly, all the other websites or your websites, based on how responsive they are, they'll get a full page screenshot of the website. So these are all the screenshots that I had captured today. And in the recent tab, you'll also get all of the screenshots that you have captured uh, in the past. And also, if you go into the recent tab and open up any of the screenshots, you also have an option to directly download them as PDFs, a zip file, share those screenshots, etc. I hope you were able to understand how screenshot testing works. Please feel free to reach out to LambdaTest if you have any questions. Hello everyone and welcome to a quick session on LambdaTest. Today, let's talk about a smart feature from LambdaTest we like to call as UI comparison. You'll get the option to open UI comparison under more tools and click on UI comparison. As soon as you open the UI comparison, you'll get a UI where on the left hand side it will ask you to upload the baseline images, and on the right hand side it will ask you to upload the comparison images. So how the UI comparison works is it compares both the baseline as well as all of the comparison images that you uploaded, and it checks pixel by pixel differences between those two images and gives you the results. How easy is it to do? On the left hand side, just simply click on the plus icon, choose any image that you would like to compare. I'm just adding, and similarly on the right hand side, you can also add comparison images as well. So here also, I'll add two images. One, I'll try to use the exact same image, and then I'll also add an image which would be totally different so that we can see the differences. So here you can see now on the screen that I have one baseline image uploaded and I have two images. One is exactly the same, and the UI has already given you a message that the image that you have uploaded, the baseline as well as the comparison, this one, the one with the black background, has a different size than the baseline image. And how easy is it to compare? So let's say you have multiple images that you uploaded, so you can click on compare all and compare all of them, or you can click on this run icon or the run button, which will automatically start comparing the images. I'll also click on compare all. Yeah. So as you can see on the screen that both of these images have now been compared, and it has now returned you the results. So I'll quickly open the exact same image first. So this image, as you can see, was exactly the same. So there is no highlights or no color because there were no pixel to pixel differences between two images. So I'll also show you a side by side view. So this was the baseline image and this was the comparison image, which is exactly the same. And we also have a slider mode where you can slide over the images to view the differences and the pixels. However, if we go back and go to this particular image, here you can see that the complete image has been highlighted in purple. That is because two of the images that we uploaded were totally distinctive. So here now if I go to the side by side mode, you can see that this was the first image, that is a baseline image, and the comparison image, which were totally different. And if I go on the slider mode, you'll be able to clearly see that both of the images were totally different. And in cases where you could try to compare images between your websites post deployment and you find any issues or you find bugs from directly from here, you also have an option to create or mark a bug as well. This was a quick overview about UI comparison on LambdaTest. I hope it was helpful. In case of any questions, please feel free to reach out to the LambdaTest support team or drop us an email at support@lambdatest.com.
Hello everyone. Today we'll be talking about HyperExecute. HyperExecute is a smart test orchestration platform to run your end-to-end tests at the fastest speed possible. On HyperExecute, we support all three OSs, that is Windows, Mac OS, as well as Linux Docker containers. So before we move on to the working session of how HyperExecute works, let me help you understand why this was built and what is the problem that we are solving. So why are traditional solutions so slow? So when I say traditional solutions, I mean the standard Selenium grids that are on cloud. So how they work is, as you can see, let's say we have a script in India that communicates with a hub that is in Singapore, and it communicates with the data center that's in Europe, and eventually, for example, your website is hosted in the US. So the script is traveling almost halfway around the globe to interact with the website and perform that Selenium test case. So within that communication, there are multiple network hops happening to and fro. And let's say if there's a slight network drop or network glitch happening in between, it may result into test flakiness, test case failures, and numerous other issues. And it also adds on to the latency, so you can see a dip in performance as well. So with HyperExecute, what we did was we packaged the first three components, that's the script, the hub, and the data center, all into a single Azure machine. And the only network hop happening is towards your website. So this has minimized the network latency, and the execution that now you can see that can be compared to a local native execution. And also the flakiness comes down to like 0%. So that's the underlying architecture of how HyperExecute works. Integrating your current test suite with HyperExecute is a two-step process. First is you have to create a hyperexecute.yaml. It's a workflow-based file that where it's written that how you want to run your test cases. I'll later move on to the syntax, how it works. And then we have the HyperExecute CLI. It's a lightweight binary that we have to place in the root of your project folder so that it can package all the test scripts and send it to the HyperExecute machine so that the execution can happen there. So I'll quickly walk you through how you can configure the YAML file. So this is my sample TestNG project. So as you can see, I have 4 Java classes which I'll be running on HyperExecute, and I have already placed the HyperExecute binary in the root of my project. And this is my YAML file that would be triggering the test. So YAML file consists of multiple parameters, and also There are two types of YAML that can be created. One is the auto-split YAML and the other one is the matrix one. So let's talk about auto-split first. So when you're running on auto-split mode, um, we have to keep auto-split set to true so that it identifies that this has to run in auto-split mode. There are some global settings, like you can set up some timeouts, you can define the concurrency. Concurrency is nothing but the number of parallel machines, VMs you want for this particular execution. Let's set it to 4 so that we can distribute these 4 classes amongst these 4 machines. With HyperExecute, you get some additional features as well. For example, I have this retry on failure set to true, which means if any test case fails, it would automatically retry that test case inside that machine up to 5 times. So I can just configure this to any number I want. Let's keep it to true for now, so that if a test case fails, it is retried twice. Similarly, we have runs on. So runs on is used to tell the binary that it has to run on this particular OS. So here in this case, it's a Windows OS. Then let's move on to the pre-stage. So pre-stage is nothing but prerequisites needed for your project to run. This can consist of n number of commands that is needed to set up that machine so that your project can run successfully. For this particular sample, we only need the Maven dependencies to be installed. So this is the command that is being used to install those dependencies. Other than this, for example, if you want to call any APIs before running the test, if you have any certificates to be installed, everything can be placed right over here. Just add in another command. You can run those and it will be executed there. After the pre-step, we have a discovery stage. So discovery stage is nothing but we are listing down individual tests so that those tests can be distributed amongst these number of machines. So that's how the auto split works. So if we get deep into it, we are using a grep command to fetch the class name using this from this particular Windows XML. So inside this Windows XML, I have 4 tests defined, and each test is running a different class. So with this distribution, it fetches that class name, and it is sent to the test runner command here, so that it dynamically puts that value, and when upon distribution, it picks up different test cases. So once your YAML is configured, you can simply use the HyperExecute run command. So that would be the name of the file, the HyperExecute binary, and the path of my YAML file that is present right over here. And also you'll have to provide the username and access key along with the run command. I have my credentials saved as environment variables, that is LT username and LT access key. So they will be picked up automatically by the HyperExecute binary. So as soon as I trigger this, it will start the execution. As you can see, it's an auto split mode. It's running on Windows with the concurrency set to 4. Yeah, these were the 4 classes that were supposed to run. So these were discovered. And as you can see, it's packaging my complete test suite and uploading the payload to the HyperExecute machines. So if we go back to the dashboard here, yeah, it detected an execution. So yeah, there you go. This is the one that's being executed. So as I set concurrency to 4, I have 4 different Windows machines that are running here. So as a pre-step, it's downloading all the dependencies. So yeah, so it's done. Once all the dependencies are downloaded, it discovers the test case. So let's say test 1 is running on this VM. On another one, we have test 2. On the 4th one, we have test 4. So once the discovery happens, then we have the stage where the actual test runs. So here you can see the live execution logs. Right. So all your console logs would be visible right over here. And to view the test execution, you can click on this hyperlink, view test detail, and it will directly take you to the automation dashboard, where you'll get to see the video as well as the command logs to the right, um, the standard automation dashboard that you see. And all the relevant information around this particular test is summarized right over here with all kinds of logs and everything. So if you click on this Selenium logs, it'll have this button to take you back to that particular HyperExecute stage on which this test was executed. So you can click on here. It'll route you back to the HyperExecute stage where this test was run. So right. So here, as you can see, we have the logs right over here. We got the test execution here. In the post steps, you can provide any cleanup activities if there are. You can define them in the post stage in the YAML. Then we have the artifact management. So, for example, if there are any reports being generated after the test execution completes, you can provide that path in the YAML, like I have over here, upload artifacts, the name and the path of that YAML within the project. So in this case, it's the target folder shortfire reports, HTML, and then double stars that it can pick up all the files. So that path is directly uploaded. All the files will be uploaded to the artifact management, and it will be available for this particular job right over here. I can click on artifacts, and once all the execution completes, I'll be able to download it right from the UI. So yeah, this was one of the execution modes that we can use, that is auto split. Similarly, if you want to run on matrix mode, matrix is nothing but you can control which test case you want to run. Now, inside the matrix, you can define all the test cases in an array. Like I have 4 of them here, 1, 2, 3, 4. Primarily, this is best suited for regression testing, and so that you can get more coverage, like over multiple OS and browser and versions. So like you can see here, I've created multiple arrays with various OSs, like all 3 OS, Windows, Mac, Linux, and multiple browsers like Chrome, Firefox, Edge, with latest version and the 99 version, and 4 of the test cases. So what would happen is, like a matrix is multiplied, all these arrays will be multiplied, and the n number of combinations would be created based on. So if I run this, let's set the concurrency to 20, and I'll run this config. Matrix. So yeah, as soon as this is triggered, it should create number of machines with all these combinations, like based on the matrix based multiplication. So it's uploading the payload. Let's go back to the dashboard. So here we can see, right, a new job is created. Let's wait for it to upload. So once it's uploaded, I'll be able to see all the combinations that are created. Right. So based on the arrays that were there, with 4 tests, 3 OSs and everything. Okay. 3 browsers and 2 versions, there were 72 combinations that were generated, right? So this is how you can test coverage with multiple browsers combinations using the matrix mode. Along with this, there are other features also that are specific to HyperExecute, like there are certain smart CI features. So when it comes to auto split mode, we are distributing all the test cases. However, so what happens is, with every execution, the platform learns. We have a smart grid in place. What happens is, once the test case is run, with every consecutive execution, the grid, the HyperExecute analyzes and it automatically reorders the test cases. So it would analyze the longer running test cases and the shorter running test cases, and to get the fastest feedback, it will distribute the longer running with the smaller ones amongst the number of parallel threads you have, parallel VMs you have, and it will get you the optimum performance based on your previous execution. The second smart CI feature would be dependency caching. So let's say, for example, if you're running your test cases using a CI pipeline on Jenkins, so for every execution, it downloads the dependencies. For let's say an example of TestNG, Maven, it would download all the Maven dependencies every time your build is triggered. However, when you run on HyperExecute, you just have to trigger that once. All those dependencies would be saved in the cache memory, and for every consecutive execution, it would directly use that cache instead of downloading it directly from the internet, which also saves some time, um, which also saves like overall build execution time. Along with this, we already talked about the retry on failure mechanism, how you can configure that. Along with this, you get deep analytics as well. So with HyperExecute, you can simply go to the analytics tab here, and so with the yeah, when it comes to analytics, you can create your own custom dashboards. So like I have it right over here, built with this. Right. So you can add multiple widgets over here based on how you want to build the dashboard. We have test case, health snapshot, overall test summary, the count, what was the coverage on browser OS combinations, what were the test trends, the pass-fail ratio, what were the job trends, stage trends, and task trends. So these three are like specific to HyperExecute because the terminologies that are used are based on HyperExecute. So each execution, overall execution, is considered as a job. Um, each VM that is allocated, that is considered as a task, and there are multiple stages within a task and overall in a particular job. So all these metrics are available, and you can build your custom dashboards depending upon what widget you want. Um, it may be like specific to test cases, or it may be like based on stage and job or task trends. Along with this, there's also another feature that where you can keep your test secrets. Basically, it's a vault functionality that we have. Um, it's backed by HashiCorp, so you can simply add a secret. It's based on a key value pair, so you can just name any variable right over here. So let's say this is my variable name, and I can give, for example, if there are any access tokens or any passwords that you want to use at runtime, you can simply add a secret like this, and you can call this test as an environment variable at runtime, because once you add this as a secret, these variables are exposed directly on the HyperExecute machine, so you can call it anywhere within the YAML within your test script as you want. So yeah, that's the basic overview of how HyperExecute works. For more information, we do have the support documentation over here, which can be referred. So it has all the basics of how we can get started with HyperExecute, along with a few examples. Language and frameworks has all the relevant repos and how you can configure the YAML, what's the difference between different types of running modes, and how you can set up the YAML based on your project. Right.
Hello, everyone, and welcome to a brand new session of LambdaTest Tunnel. Most of you might be thinking that up till now, what we were discussing were around public URLs, public application that can be accessed all around the world. But what if we want to access an application that is behind a firewall, cannot be accessed publicly, or can only be accessed on the internet? or even if it is a localhost application. So for this particular use case, if you want to test out any of these applications on the LambdaTest platform, we have built a utility we like to call as Tunnel. Tunnel is nothing but it creates a secure SSH connection between your network and the LambdaTest device on which your application or web app is currently being running. How we can configure or start this tunnel is very simple. On the top right side, you can see a configure tunnel option, which as soon as you click, you'll get two options to connect to tunnel. One is the command line, where you can simply download this file, which is a binary file that can be downloaded into your folder. From that folder, you just need to extract that file and run this particular command by traversing into that folder, and you'll be able to access the tunnel. And then second is a desktop app, which is a much more intuitive way to use the tunnel, and we like to call it as UnderPass. In order to demonstrate how the tunnel works, I'll quickly be using the desktop app we like to call as UnderPass. I already have the UnderPass application open on my system, and how easy is it to configure the UnderPass is by simply entering in the LambdaTest username or credentials, username and access key onto the UI. From where you can get the username and access key is either from this command line, you'll get both the username or access key, or you can even get it from the profile section or from any of the automation dashboards by clicking on the key or the access key icon. Once you have the username and access key, you can basically put any name of your choice for the tunnel and then simply click on start to launch the tunnel. However, before launching the tunnel, I would like to also go through some of the features that the tunnel has. You can see here. First one is shared tunnel. So let's say if one of the tunnel that you're running, you executed that tunnel on a server which has a very high speed, and all of the team members would like to use that same tunnel. In that case, for any of the team member to use the shared tunnel, you need to enable the shared tunnel flag. The verbose is to basically get the detailed logging for each request that is passed through tunnel. MITM basically stands for man in the middle. So for example, if you have applications or websites which do not have a public certificate and cannot be opened on public browser, so for those cases, MITM will automatically handle those. Then on the advanced configurations, we also have proxy host, proxy port, proxy user, and proxy password. Let's consider a situation where you need a proxy to be configured, and only through that proxy you will be able to use the application. So Tunnel gives you the capability to do that as well, where you can enter in your proxy's proxy host, her port number, and if it's a protected proxy, then you can also add in the username and password in order to connect to the proxy and then finally connect to the application that is behind that proxy. Also, from the tunnel, you can directly access your local uh, directory. That is, you can directly pass in the local server directory path and directly accessing any of the web applications here. So for example, if your current web app is under development and you have not published it and it's still in your local directory or a local server, you can simply pass in the file path or directory path of that server here, and you can directly access that folder on the LambdaTest browsers to see how your local application looks and feels like on a browser. So now I'll quickly click and start the tunnel. I'll just disable these for now, and I'll simply click on launch. As soon as I click on launch on my UI, you'll be able to see that in a few seconds it has went to running state. And if I go back to my dashboard and refresh the page, on the top right where I see the configure tunnel, you'll be able to see now one tunnel running. Now, in order to demonstrate how this tunnel works, I already have my local server running, and which is on port 8000, And if I go to my browser, I already have that opened up here. Now, if I copy this URL and let's say I want to open it up in one of the LambdaTest devices. So I'm going into real-time testing under browser testing, and then I'll add the URL here. This is a drop-down which you need to use whenever you have the tunnel. So just to demonstrate, I'll first disable the tunnel for once, select a browser, let's say Chrome 103, Windows 10, and simply click on Start. So here you'll be able to see that as soon as the browser launches, it should throw us an error because the localhost application that is running, that cannot be accessed here because it's running on my local system, and this particular system, which is currently resting in a data center, does not have an idea of where this localhost 8000 call should go. However, as soon as I'll end the session, and in this time I'll connect to the tunnel and I'll relaunch the same session again. Now you can see that the same localhost application that was working on my local is now getting accessed on LambdaTest as well. In the similar manner, any of the applications that you're currently running locally or is behind a VPN or cannot be accessed publicly can be tested out of any of the LambdaTest browsers, real devices by using tunnel. LambdaTest tunnel can also be used in automation testing as well. And in case of automation testing, the only thing that you need to do is use a capability. So for capability, go to an automation dashboard, for example. From here, I'll open the capability generator. And if I scroll down, here you can see there's a capability called local or tunnel. You just need to turn this on, which will in turn return a capability called tunnel is equal to true. So to run any of your automation test cases, may it be browser automation on real devices, browser automation on desktops, or on simulators, or even app automation, if there are some files or some API calls that can only be made when it's behind a VPN, or the complete website can only be accessed when it's behind a VPN, you just need to pass in the capability tunnel true and start your tunnel, and all of the tests that will run with the tunnel true capability will be able to access your local application. I hope this session was helpful. In case you have any questions on the LambdaTest tunnel, please feel free to reach out to the LambdaTest support or drop an email at support@lambdatest.com.
As you all know, LambdaTest is a platform in which you can run multiple tests to test your application. But down the line, when your test gets bigger, we often run into a problem of visualizing our test. How many tests went into our error state, and so on and so forth. We took this as a problem and we introduced a brand new product in LambdaTest called LambdaTest Analytics. LambdaTest Analytics is a platform in which you can visualize all the tests that you run across different products in LambdaTest. So let's get started without any delay. As you can see on my screen, logging into LambdaTest.com, click over this section called Analytics. On clicking this, it gets you routed to analytics.lambdatest.com. If you have not created a dashboard, you just get started by creating a dashboard. But if you have already created some dashboards on your demo, then you could see all the list of dashboards that's listed down over here. On the left side, you can see all the favorites dashboard and the recently visited dashboard. But let's get started by creating a brand new dashboard so you can get an idea. Over here on the right top corner, clicking on Create Dashboard opens a large pane which gives you a collection of widgets and a small area which you can input your own dashboard name. So let's add a couple of widgets. So for the demo purpose, I'm going to add Test Trends, which gives you a visualization of all the trends of your test, error stats, different visualization of different tests into different error states, and test summary. Okay, so let's name it as production test dashboard. That sounds pretty cool, right? Okay, that's it. So these widgets are classified according to various products that's available in LambdaTest. Analytics currently supports web automation, app automation, and HyperExecute as such. So boom, let's go create a dashboard. Okay, on clicking this, a dashboard gets created with all the beautiful add widgets. Now we have test summary, error stats, and test trends. Okay, so by default, these widgets are configured based on a date range, which is 1 month. You can choose custom date and time within the date range of 90 days, right? Cool, all good, everything pretty thing, everything looks fine for now. So, but you might be thinking like, what if I want to configure this particular widget or this widget or this widget based on my preference or based on my configuration, right? Yes, you can pretty do that. So clicking over this pencil icon called Edit Widget opens a small panel which gives you all the different configurations that you can do on this particular widget. So based on projects, builds, test name, and so on and so forth. So let's go and try it out. So over here, I'm going to just want to configure this widgets based on the test that ran in Chrome. So I'm going to delete all the different browsers that's there and just select Chrome for this particular purpose, right? Um, okay, update widget. And there we go. We get the test trends widget updated based on all the tests that ran for this particular date range in Chrome browser. Okay, so what if you want to specifically look into February 4th till something around, February, or maybe say, yeah, February 8th. Okay, so February 4th till February 8th. Yeah, 4th till something around 8th. Okay, this is how my test performed. Well and good, pretty good. So my previous was 456 and comparatively I'm a little bit low over here. That is 366. Okay. So previous month at this particular point of time, we had ran around 366 test, 456 test, and you know, over here it's just 366. Okay, cool. And what if you want to visualize this in a bar chart? Clicking over here, you can switch the graphs into line as well as bar. And if you want to go back to your default state, click on this home icon, which gets back to you to the default state where we started. Okay, these all gives you a good information about which widget, which product are you visualizing and what's the widget name that you're chosen. And okay, so, and this also gives you a good information about what this particular widget means. Okay, all good, sounds good. Everything is working well and fine. What if I want to create a clone of this particular widget with the exact same settings? Yes, so for that, we have something called as clone widget, where in which you can clone the exact same widget in the same dashboard. Clicking over here, add, it clones the widget, the same test trends widget into the same dashboard, right? Okay, so that's good. Now I want to edit this widget and call it as test trends. Maybe, okay, here the browser is just Chrome. Maybe we will be making Chrome and Windows, right? Windows, or maybe Mac OS. Mac OS. Okay, so over here, I'm going to select my preference of OS into just Mac OS. So I'm going to uncheck all the other ones. Okay, I'm going to choose Mac OS from here and update this widget. Boom. So the widget gets updated. Now we have the test trends of all the tests that ran in Chrome and an operating system of Mac OS. Wow. So let me rename this to just Chrome and maybe Chrome and Windows, right? Okay, and here we go. OS, I'm just going to select Windows. Okay, okay. Oops, by mistakenly, I just unchecked all of them. So let's go and select Windows over here and update the widget. Cool, it's going to get updated. Okay, That looks good. Now I get a clear visualization of what are the tests that ran on Chrome and Mac OS versus Chrome on Windows, right? But this is kind of difficult to compare. So I just, because I have to scroll each and every time, right? What's the solution for this? So over here, now we have given a feature where which you can customize your dashboard based on your preference. So clicking over here, edit layout, it gives you to the edit mode. So you can resize your widget and, make it according to your preference that you like, which makes life easy, right? So I'm going to resize this widget in such a way that I can visualize or compare both these widgets easily. Okay. So I'm going to move it up over here and I'm going to increase this a little bit. Increase this a little bit over here. Okay, that sounds good. And I'm going to save it. Okay, so saving this layout, okay, it gets me a clear picture and I'm getting happier because I can compare, I can visualize both these widgets, both the trends of Mac OS with Chrome versus Windows with Chrome, right? So let's go. Yep. Okay. This performed pretty well. Feb 16th. Um, this 812, and here Feb 16th. Okay. So this is how we do a comparison between different tests that we across different configurations, right? So okay, so now what if you want to share this information with your management, right? How do you do that? So we have something called as share dashboard, but before that, you can visit dashboard settings to see the different settings that is available before you share. You can share with a custom password. Clicking over here, you can set up a custom password so that it would be secured, or else you can change the expiry to from default to 7 days. You can change it to 15 days, 30 days, never. That would be an infinite link, right? So I'm good with the default settings right now, and I'm going to click this button up. So let's see. Okay, so we get the dashboard link. I'm opening a new private window so that we can see how it works. Okay, I'm going to paste this over here. Cool. Okay, we're getting into the dashboard. Cool. So here we get a clear picture of the dashboard that we shared, but the user that's viewing only gets to read the information. He never is allowed to do any tweaks on this particular graph. And that's exactly what share dashboard must do, right? Okay, so that's all about dashboard. So let's go back to our dashboard and see what are the other things that we offer. So let's go back to our homepage. The homepage gives you a list of all the dashboards that you've created. You can start the dashboard so that it becomes into your start area, so you can easily access them, right? You can edit this particular dashboard, and again, if you want to clone this particular dashboard again, so you just need to press this button over here and it gets cloned. That particular dashboard gets cloned exactly the same way, and you can edit the name of this particular dashboard as something called dashboard 2. So dashboard 2, right? Click save over here. Oh, so that's done. And that's it. So if you want to delete, if you think that this particular dashboard is unnecessary, then you can go ahead and delete this particular dashboard, right? Okay, so you're going to delete this particular dashboard. That's it. Okay, I think I just forgot one more cool feature that we had. So going into a dashboard, you see if you feel that you want to export a particular widget as a PDF, you have an option called as download as PDF. You click over this, but get this exact same widget, you know, you would get this exact same widget as a PDF format. So let's see how it gets done. Cool. It's downloading. So let me click it once more. I think I clicked it wrong. Okay. Oops. Yep. Download PDF was successful. We got the notification, and here we go. We save it. We save the dashboard, and it gets downloaded. We open it up, and here we go. We get a clear picture of what our dashboard looked like. So I'm sorry, why is this not rendering? Okay, cool. So yep, this is a clear view of what you got downloaded as a PDF. Yep, that's pretty much what analytics and lambda test offers. I hope you guys would try it out and let us know what you feel about lambda test analytics. Thank you. Have a great day. Bye bye.
Today, we'll talk about LambdaTest integrations. LambdaTest supports more than 120 plus integrations with different bug marking tools, project management tools, communication channels, CI/CD tools, etc. All of these integrations are mostly one-click integrations where you can integrate with these tools by simply entering in your credentials, your API token, and that's it. Where this integration helps you or comes in handy is in the bug one-click bug logging that I demonstrated in one of my previous videos. These integrations helps you to directly log a bug from LambdaTest directly to your project management or bug marking tool, or send that to your communication channel as well. How easy is it to integrate? So I'll take an example of Jira. I'll simply click on Jira here. We support integration of Jira of both cloud instance as well as a self-hosted instance as well. So how to integrate Jira? You just need to simply enter in your official Jira URL for your organization, enter in your email address, and once you do that, you need to create an API token. How you can create an API token? For that, we also have integrated or a clear documentation which you can refer through to, which helps you with the complete integration. Or you simply need to go into the manage profile security API token section on Jira, where you can simply create an API token, give it any name, create it, copy the particular API token that's been created, and close this. Go back to the Lambda screen, enter the API token, and click on install. As you can see on the screen, the integration is done and my Jira has been integrated. This might take a couple of minutes because a confirmation email you'll get on your email. And also, on top of it, what we do support is not just one, but you can have multiple integrations in one single account. So let's say if in your organization you're not just using Jira, but you're also using Mantis, Zipboard, or Asana, Trello, etc. So in this one particular account, for bug marking or project management tools, you can have multiple integrations, but for communication channels, you can only have one communication channel integrated with one single email address. I hope this was pretty easy. Any questions here? I'm more than happy to answer. As you might already know, LambdaTest supports over 120 plus integrations with different bug marking tools, project management tools, communication channels, CI/CD tools, and codeless automation tools. Today, let's talk about how easy is it to integrate with a codeless automation tool Katalon and run your tests directly from Katalon to LambdaTest. So you might already know the Katalon is a codeless automation tool which allows you to record your scripts directly by just entering in your web URL, and then using the Katalon recorder you can record all of the actions and then later play the recording to execute your scripts. Here that you see on my screen is a recorded script that I have where I'm just simply opening the LambdaTest website, logging in and logging out of it. Let me first showcase how easy is it to run this on a local browser. So here, as soon as I click on this play icon, you can see that the test has started running on my local Chrome. And in a couple of seconds, you'll see a Chrome window popping up where you'll see the complete execution of the test. So this has now opened LambdaTest, it's logging in, and it will now log me out to complete the test session. Now I would like to run the same test case, but this time I would like to leverage the LambdaTest inventory. How I can do that? To integrate Katalon with LambdaTest, you simply need to go into Project. In Project, click on Settings. Under Settings, just go into Desired Capabilities and click on Remote. Under Remote, you'll have to configure both the LambdaTest hub URL along with the username and access key as well as the capabilities. You might already know from where you can get the LambdaTest hub URL. That is, go into the LambdaTest automation dashboard, and it's on the top right under the access key icon, which will just load up. You can just click and you can copy this first link which says hub, and you can paste it here in the remote URL. And then you'll have to add each and every capability that you want to run the test on. So for any of the tests to run, you might already know that the basic capabilities are the browser, platform name, version that you need. And on top of it, you can also add other capabilities like name or build. And how easy is it to add? Just click on add, enter the name of the property. So let's say I want a network log, so I'll write network and I'll change it to Boolean and the value to true. And from where you can get all of the capabilities that Lambda supports is from the LambdaTest capability generator. So from here, under Selenium, you can select all of the capabilities that you require along with all of the different logs, test names, everything that you want, and you can add those capabilities under the desired capability object. Once you add all of this, the only thing you need to do is apply the changes, apply and close. Once that's done, under this drop down, you just need to click on remote, and you can see on the top right, the test case now has started running on the LambdaTest URL. Now, if I go back to the automation dashboard, you can see on the top a few seconds ago, a new test has just started called Test Katalon, and the test has started running. And as you can see in the capabilities, I had selected Chrome 107, Windows 10, so test has started running there. It has also taken the names that I've added, and the test has been completed. So this was how easy and quickly you can integrate your Katalon tests with LambdaTest. In case you have any questions, please feel free to reach out to us at support@lambdatest.com. Today, we'll be talking about how you can easily integrate any of your test cases that you've recorded on Katalon through HyperExecute and leverage HyperExecute to run those tests on LambdaTest. This that you see on the screen, as you already know by now, is the HyperExecute dashboard. But before we talk about the dashboard, let's go to the Katalon. So here, this is the Katalon project, and you might also have something very similar where you'll have a few test cases and then you'll have a test suite. By test suite, what I mean is a test suite on Katalon is a collection of all the test cases that you have written. And since in Katalon, the parallelization works on a test suite level, so for each and every different machine that you want to be allocated on HyperExecute, you'll have to have a different test suite. How you can create a test suite is by just simply by right clicking here, create a new test suite. So as you can see, now I have two test suites. Now let's talk about how you can integrate this particular suite with HyperExecute. As you already know, to execute or run your test cases on LambdaTest, you need two basic things. First is the LambdaTest username, access key, and the hub URL, and the second is the capabilities. In a very similar way, even in Katalon, you'll have to set up a remote capability or a custom capability under which you'll specify all of these. How you can do that is by going into project, click on settings. Under the desired capability head, go into custom. Here you can see that I have created two custom capabilities. One is for Firefox and second one is for Chrome. And inside you can see that it's a remote capability. So if I go inside, you can see my complete username, access key, and the hub URL, LambdaTest hub URL added here, and the capabilities on which I would like to run my test cases on. I also add a name here. This is it. Once you add all of the capabilities, you just need to save it. You can simply click on apply and close. You want to simply run this particular test suite on any of the custom capabilities directly from Katalon. For that, you just need to select the test suite and you simply to select the custom capability you want to run this on. And I'm sure you already know this by now. So now, if you want to leverage HyperExecute and run these tests through HyperExecute, you'll need to do an additional step. That is, for HyperExecute, as you already know, that it's a YAML-based workflow. So we need a command using which you can execute this complete suite or setup, and then you need the HyperExecute CLI to be present in the root of your project. So first, let's see how we can get your command in order to run this execution. To get the command in Katalon, just go into Window, click on Command Palette. As soon as you click on Command Palette, it will give you a pop-up where you get a few options. Under this, just click on Generate Command for Console Execution. As you do that, you'll get an option to select the suite that you want to run your test cases on. You can select the platform that you can select from different custom capabilities that you've created. So I'll click on Edit and I'll click on Firefox that I have created as a custom. In Profile, you can keep it as default, and then you need a Katalon API key. This Katalon API key is required because it validates if you have an active license of the Katalon runtime engine that is used at the time of execution. If you have all of this set, you just need to simply click on Generate Command, and this is a command which you can simply copy to clipboard and use it on the HyperExecute YAML file. Here, this is a project that now I will be running from HyperExecute. This is my root folder under which I have the HyperExecute CLI already, and then I also have the HyperExecute YAML file. This is the YAML file as you can see on the screen, and on this YAML file, one thing that I've already added is the command that I copied. So this is the Katalon command that I copied from the Katalon console to run the test cases, which has the API key and all of the different configurations. And then this is the test discovery step. So this is the command that you'll be using for identifying your test suites. So those test suites will be distributed here, and then those test suites will get automatically executed. How this command will find out your test suite? So if I copy this, as you can see, there are two test suites. One is demo 𝐼𝐸x and the second one is 𝐼𝐸x sample. So both of these test suites will be used in my runner command at the time of test execution. Now, since I already have my HyperExecute CLI here, I have my I've already found out my test suites and I have my runner command. The only thing that's left to do is just to simply execute this. And how I can execute this is using the HyperExecute command. That is HyperExecute, then my usage game and access key, and then the configuration which holds the YAML file that I've created. So that's it. I'll just change the concurrency to 2 so that 2 different machines are located. So once this is done, I'll simply click on enter. As you can see, it has already started. In Windows, concurrency is true, and it has successfully uploaded the payload. Sorry, it's uploading the payload. Now if I go back to HyperExecute, you can see here the tasks have already started, and here in the pre-steps, if I go into discovery, you'll be able to see that it has discovered those 2 suites that it has to distribute and run. So in a few seconds, this will start the execution and it will start running. In the meantime, this executes. I'll just quickly take you to an older execution that I just did with one of my suites. So here, if I go here, you can see in the discovery, since I just had one single suite because the second one I just created on the video, and in the scenario, you can see that the tests were executed. And since in this particular suite, as you saw that I have 2 test cases, so here on the automation dashboard, I have 2 different test sessions created. Although both of them have been executed on the same HyperExecute machine, but both are 2 different sessions that were executed. And if I click on View Test, it will automatically open the automation dashboard, under which it will give me all of the details, that is the execution video, all of the command logs, the network logs, everything that we provide on our normal standard automation grid. So as you can see here also, the test has been executed. One of them failed with some error, and the one of them passed as well. So this was how simple is it to integrate HyperExecute with LambdaTest. In case you have any questions, please feel free to reach out to support@lambdatest.com. Today, we'll talk about how we can integrate HyperExecute to run through a Azure DevOps pipeline. As you already know by now that even Azure DevOps and HyperExecute both run using a YAML file. That is, both of them require a set of commands described in a YAML file to perform the commands on the described machine. As you can see here, I already have my repo uploaded into my GitHub account and I have a HyperExecute YAML already pre-configured. This is a Java project, and for my Java project, I already have my pre-steps, my post-steps, my test discovery, as well as my test runner command pre-added. And in the same way, I'll also be needing another YAML file, which will include the HyperExecute CLI and then the HyperExecute runner command for Azure so that those particular steps are executed on the Azure machine and then my HyperExecute command runs. So here is an Azure YAML which has a command to install the HyperExecute CLI directly on that CI/CD machine, and once that CLI is installed, we are just simply running our test command. So now how we can integrate with Azure is I'll go into the Azure DevOps pipeline. I'll create a new pipeline. The new pipeline, I'll select my code, which is currently in GitHub. So this is my current code base where I have it. So I'll select this. Once I select that, it will give me different options to either configure your pipeline with the pre-recorded steps or to use an existing Azure YAML. Since I have an existing Azure Pipelines YAML, I'll use this. I'll select the branch that I want to run and I'll select the YAML file. Once I have selected, I'll just simply click on continue. And here you can see that it has started showcasing my YAML file here. Once all of this is set, I'll simply run this. As you can see now, the job has started. It is currently queued, and in a few seconds, once all of its pre-steps are done and it prepares and it gets the machine available, it will start the job. It will start running the HyperExecute test directly from the Azure pipeline. So I'll wait for a few seconds for the command to reach the command line. So now you can see it has reached the command line where it is installing the HyperExecute CLI. As you can see the version, and once that's installed, it will now upload the payload into that machine. As you can see that the payload is uploaded, and now it will start running the test cases in a few seconds. So now as you can see, it has started running the job. I'll quickly go back onto my HyperExecute dashboard, and as you can see here, the test has already started. As you can see, I have 5 different machines that I had selected, and based on that, it has located me the machines. And if I go into the pre-step, click on discovery, you can see there were 10 test cases that were discovered, and all of the test cases have been equally distributed amongst the 5 machines. As you can see, all of the test cases have been executed. This is how simple it was to integrate your existing HyperExecute test DevOps pipeline. In case of any questions, please feel free to reach out to support@lambdatest.com.